Hello, my name is Audrey Gallier, and my final project is on predicting historical menu prices. So this was a regression task to predict prices of items on a menu based on the dish, characteristics of the menu, and characteristics of the restaurant. And I used a historical data set containing info on menus mostly from the early 1900s, but it had menus from the 1840s till today. And I mostly did this project for fun, but it also has some real world applications, like predicting trends in prices or predicting how inflation will affect food prices, and for restaurants making marketing or pricing decisions. So to represent these features, the dataset had a really diverse set of features. Some were categorical, some were text, some were numerical, but I wanted them all to be numerical features on the same scale to train the models. So for categorical features, I used one-hot encoding to make them into numerical features. And then the challenging features were the text-based ones, such as location, which had names of hotels or names of restaurants, dish name, which had the names of the specific dish being served, like chicken salad or broiled fish, and then physical description, which was just a random list of physical attributes. So for those, I got the most common words in that column, and then I made those each into a separate feature with one-hot encoding. So I ended up extracting useful information from those text-based features and putting it into numerical features. And then I used min-max scale to scale all the features between 0 and 1. Then I did some exploratory data analysis. The price was the target variable, so I did that first. On the left, you can see how the prices are changing over time. So you can see it staying pretty constant until around the 1970s when it started to go up, which is likely due to inflation. Then on the right, you can see the distribution of prices across the whole data set. Most of them were under 5, but there are a few outliers going all the way up to 30. I also did some data analysis on the features, and this was the most notable too. So at the bottom right, bottom left, you can see the most common words in the dish name across all of the menus. So the most common were salad, cream, chicken, potatoes, and fried. So I thought it was really interesting to see what words were being used and what types of dishes were being served during these time periods. Then on the top right is the distribution of dates throughout the data set. So you can see that it's kind of unbalanced. Most of them are from the early 1900s, but we also have dates from all of the decades covered by the data set. So for models, I trained and tested 5 models: linear regression, decision tree, random forest, AdaBoost, and neural network. And then for each of these models, if it was applicable, I used grid search CV to do hyperparameter tuning. So for decision tree, I did hyperparameter tuning for min sample split and max depth. For random forest, I did it for n estimators, min sample split, and max depth. For AdaBoost, I did it for n estimators and learning rate. And for neural network, I actually didn't do the hyperparameter tuning because it was taking way too long on my computer. So I designed the neural network based on what we learned in class, which was that each subsequent layer should have fewer nodes than the last one, and the first layer should have fewer nodes than the number of features. So I actually used all 79 features for that neural network instead of doing feature selection like I did for the other models. And then this is what happened. So basically, AdaBoost and linear regression did not perform that well on this data, but they also had the least amount of overfitting. And I think that's because they didn't really get a chance to learn the training data that well in the first place because they weren't able to model it accurately. So then they weren't going to be overfitting. And then the best model to perform on the data was random forest. So while it did have the highest amount of overfitting, it did reach the highest R squared score on both the training set and the testing set. So random forest is the one that I would recommend for this problem. Here's those interpretations that I just said, put out in bullet points. Another interesting thing that I noticed was that the date that the menu item first appeared on any menu largely contributes to the price, which is cool because it shows that the prices are changing over time. So yeah, this project was really fun to do, and I learned a lot about what kind of things were being served, what places in different periods of time. And I'm really happy with the results and surprised that I was actually able to predict these pretty well.